Okay. So previously we have used the for to assign values from a group of indices or index. So this is from 0 to 1, 2, 3, 4, 5. Actually, you can use for loop to assign this I into any kind of groups. So we can have integers, we can have maybe real numbers, float or double precision, and we can also have text on any kind of object or subject. So here, you can say for I in X, which means we are going to visit every element inside X. And actually Python doesn't care what kind of data is that type. Python will just go to every element, every member inside X and put that number under the name I. And then every time you run all the lines inside this for loop, so here I is always a member of X, which means it is a real number. And then we calculate the square of it and we add it to my sum. So on the right hand side of the equation, we get a number from Python. So now from the right hand side, Python has a number. And then we have this equal sign. So Python knows that you want Python to put this number into a place. And the name of this place is my sum. And this is what it means by this for loop. And last time, some students said, okay, I can do everything vectorized. Do you know how to do vectorization for this one? It's easy. Say, there it is. Y equals to very concise, right? So the first way is usually what we do for any kind of arrays or whatever thing. And the second one is a special form that Python allows us to do. And the third one is called vectorization. It is so more and more concise. This is about our assignment last time. So today we are going to continue on our loop control or on our flow control. So I guess you still remember we are doing for loop. And so with for loop, we have to go to every element inside a group or something. And what if we want to skip or just leave that loop? So here we have break and continue. These are two commands that can save us from some tedious wrong procedures or mistakes. So before we do anything, just import our old friend, NumPy. Okay. Pardon?
We need to start this in a new file.
This is what I do with it, because the last file was for the assignment I gave you last time.
I wasn't here on Monday.
Well, so you can just refer to the video I published online. And so this one is just a new file. So if you don't have an old file, of course you have to start a new file, right? So today we're going to talk about break and continue. So let me just first give you an example. For x in range 0, 4. What? Oh, sorry. So what will this do? So this line will start for loop, and it will run 4 times. So 0, 1, 2, 3. And let's see, print x. 0, 1, 2, 3. So every time your x gets one member from this group, which is range 0, 4, means 0, 1, 2, 3, and it prints out the x. So what we don't want it to output x equal to 2. Continue. Continue means, so anytime if a for loop, when it's running, if it sees continue, it will skip all the lines inside this for loop after this line and directly go to the next element inside this group. Let's try this. 0, 1, 3. So when x equals to 0, so with x is not 2, so this line is not run. We not run, and we go to this line to print out our x. When x equals to 1, the same thing. When x equals to 2, now x equals to 2, so we go into this if structure. It says continue. Continue tells the loop to skip everything behind this line and directly go to the next element in this group. So this line was not run, and we directly go to x equals to 3. And x equals 3, so we print x again. This is continue. And then let me show you what break does. Zero and 1. 3 is also gone. Why? Because anytime you tell Python break, it means just totally exit from this for loop. And I no longer want to stay in it. It's just like break up in a relation or something. Yeah. Yeah, like in a relation, if you quarrel, argue with your loved one, and you are not happy, so we say, okay, let's stop this and continue on. So you go to the next day. That is continue. But if you are just got enough of it and you just want to stop everything, so you break and you break. Same here. Mm-hmm. Pardon?
It goes to 0 to 1, so it does 1.
So if we don't have this, it will go 0, 1, 2, 3. If we continue, so when x is equal to 2, we say continue. This line won't run. So this line just skipped. Yeah. But it will say break. Anything after 2 won't go. So if you break up with your boyfriend or girlfriend, you won't get married with him, right? So you break.
So if it's a double equal sign, it's saying if x is not equal to 2.
Double equal means you want Python to check whether it is. Not equal should be, yeah. So if x is not 2, let's see. If x is not 2, continue. So first time x equal to 0, so it's not 2, so continue. Second time x equal to 1, it's not 2, so continue. Third time x equal to 2, oh, now it's not 2, so it's not continued, and we finally reach this line, we say print x. And the fourth time x equals to 3, again it's not 2, so we go into this if structure and it says continue. And I'm going to just keep the double equal here. Let's do one more. Exercise, break from nested loop. So what if we have multiple layers of loops? For example, for I in range, let's say 0 to 3. I don't want too many outputs. And let's have a nested loop for j. Range again 0 and 3. And we print I and j. So we see a lot of outputs. So the first time I equal to 0, and inside this j goes from 0 to 2, so 0, 0, 0, 1, 0, 2, and then I equals to 1, so 1, 0, 1, 1, 1, 2, and so on. What if we add a control here? So if j equals to 1, break. What do you think will happen? Let's add some message to see this clearer. So for I equal to 0, and we go to the inner loop, j equal to 0. Now j is not 0, not 1. So we print ij, we get 0, 0. And then I equal to 0, j now goes to 1. J is 1 this time. So it goes into it and says break. So now we have terminated the inner loop, and we go to this line, print end of j loop. After this, we continue in the for loop, in the I loop, because each one of the break, it only frees you from the nearest relation. So for this one, the break, the direct loop outside it is this j loop. So we break from the j loop, but we're still in the I loop. And it's the same with continue. Let's try. So this time, so every time j equals to 1, we don't print out the I and j, but we go on in the j loop. So here we can have 0, 0, 0, 2, and when I equal to 1, 1, 0, and 1, 1 is not printed, so 1, 2. And again, 2, 0, 2, 1 is not printed, so 2, 2. That's it. So this is how we control our loops. So actually, with some control like this, we can do more. So for loop is designed that we know how many numbers we're going to loop around. So for example, I know that in this classroom we have 55 students registered. So I know if I want to maybe register the name of every student or grade their homework for everybody, I know that I am going to do the same thing for 55 person or people. But what if I don't know how many students I'm going to have? Or for example, our UT, every year we have a lot of applications from all around the world. We don't know how many applications we're going to have. Maybe we'll have this pile of application information, and we'll just go from the top of the pile and go to the end. We know that we're going to stop when there is no more application, but we don't know how many. So how do we do that? We need another loop, which is called while loop. So we use a for loop only when you know how many times to repeat. And what about while loop? Use while loop when you don't know.
What about it goes through I first, and then J, and then does all the commands for J, and then returns
Pardon? So you're asking about this?
that one? So it goes first through I, and then through J, does all the commands for J, and then returns to I.
So for nested loops, so in Python, this line was first run, right? Then it goes to this line. This line tells Python to repeat the following several lines. And this for loop tells Python to repeat these following lines.
Okay, so first it goes all the J, and then
Yes. So not only the things inside this loop are repeated, also this loop itself is repeated because we have a loop outside it. This is called a nested loop. And you may have 3, 4, whatever number of loops nested one inside another. That's possible, although not recommended. So let's have some exercise. And let me show you how while loop works. For example, I'm going to continue the numbering of last time. While loop. Let x equal to 1. And let's keep dividing x. In half. Until what? Until it's very small. How small? Let's say it is less than 0.1. Okay, it's small enough. How do we do that? So first, let x equal to 1. Now x equal to 1. While loop. While what? While the following thing is true. So while x is larger than or equal to 0, we have to do something. We do what? We do x equal to half of x. And we print x. Let's see what we get. So originally we have x equal to 1. Then we go to this while loop. So while, and this is a sentence or just an assertion or an equation, whatever, but it returns a true or false data type thing, which tells, so while if this is true, I go into it and I repeat every line inside the while loop again. And if the thing after while is no longer true, we exit this loop. And in this case, so first x equal to 1, and then we go into this while loop. The first time x equal to 1, it is larger than 0.1. So we do x equal to half of x. Now x is 0.5. And when x equal to 0.5 is still larger than 0.1, so we go x equal to half of x. Now it's 0.25. Again, now x half of x is 0.125. And it's still larger than 0.1. And again, we do x equal to half of x. Now it goes to 0.0625. Now this time, it is smaller than 0.1. So we no longer repeat and we exit. This is how while loop works. And so since we have while loop, so actually for loop is just an easier version of while loop. For example, if we say x equal to numpy dot array 1, 2, 3, 4. So if we want to, last time we've done the sum of x, right? So my sum equal to 0 for I in range 0, 4. My sum equals to my sum plus xi. This is what we have done last time and also in the assignment. How do we do this with a while loop? So we need an I. Let's do it from 0. So while I is smaller than 4, my sum equal to my sum plus xi. I equals to I plus 1. Print my sum. Hey, wait. Yeah, what's the problem? I forgot to reset my sum to 0. So we can see these are the same thing. So for loop is actually it automatically created an I, and every time for loop moves I inside the group for you, so you don't need to write these two lines. That's the difference between a for loop and a while loop. So actually, everything we do with a for loop, we can do it with a while loop, but the things we do with a while loop, it's a bit difficult to do it with a for loop. Is this clear?
It's better to go with while or for.
So it depends on what kind of task we're doing. Use a for loop when you know how many times you're going to repeat. Use a while loop when you don't know. So it solely depends on whether you know how many times you're going to repeat. Because a for loop is more concise when you know how many times to repeat. Now let's do one more exercise to show you how while loop works. Exercise 4. Again, while loop. Find the first triple that satisfies what? A multiply A plus B multiply B equals to C multiply C, where B equals to A plus 1, C equals to A plus 2. And we start with A equals to 1. So we know that there are infinite numbers of integers in this world. So this time we don't, and we're going to repeat a lot of times to check whether a squared plus b squared is c squared. We don't know how many times we have to repeat. So this time we have to use a while loop. While. And so a is from a equal to 1. So let's first a equals to 1. So while let's set a limit. So let's say a is larger than 0 and a is smaller than maybe 10,000. I don't want to go too far. So this is possible, and if you think this is not clear enough, you can add a parenthesis. This is what it means. So everything on this line behind the while is one sentence, one expression. So let's do the while loop. Pardon?
Is that supposed to be a capital C?
Oh, it doesn't matter. So here's just a comment. So it's a typo. So let's do b equals to a plus 1, c equals to a plus 2. This is what we have here. Add some space to make it clearer. Oh, I forgot one thing. A equals to a plus 1. So let's check. If a times a plus b times b equals to c times c, print a, b, c, and break. So continue and break, it works for any kind of loops, which means it works for for loop and it works for while loop. It does the same thing. And okay, let's see the result. 3, 4, 5. Yeah, from we know, so square of 3 is 9, square of 4 is 16, square of 5 is 25. So yes, it's correct. Now we have our answer.
Wait, so what is this saying? Okay, so it starts off with a equals 1, and then it's saying, well, a is 0.
So actually we don't need this line. We can just say this is just a safety insurance policy. So we can also do this. This is highly not recommended while true. So you have to make sure that you exit this while loop somewhere. And so here is one control that you can exit under some condition. If you don't have this, you have to put a break somewhere inside this while loop. If we don't, for example, let's say maybe if a equals to 10, let's see what will happen. It will never exit this while loop because there is not a group of numbers a plus 1, a plus 2, where a squared plus b squared equal to c squared. It doesn't exist. So your computer will just keep going, go to the next integer from 1 to 3, 1, 2, 3, 4, 5, 6, 10,000, 10 million, 10 trillion, and it will never stop. That's why we need something to stop us. And that's why we want to say, while this. Actually, you can write this inside the while loop. If a is larger than 10,000, break. This time we see there is not that star, which means it's already finished. And print finished. You see, finished. So here I have a control. If a is larger than 10,000, it exits. But since we have a chance to write it here, it's better to write it here. It's more concise.
You want it like the top, the one with the pound sign on it?
I mean, not I want, but you will want to do that because it's more concise. It's easier to read for yourself. Or we say maintaining or maintenance.
But we're supposed to put break.
So you will always have to exit the loop. You cannot stay there forever. And you have to always have some kind of control. This is one type of control. So when this is true, you can repeat. When this is no longer true, you exit this loop. But if you put a true here, it will run infinite times. And you have to put something here to make sure that it will exit at some point.
Why not doing that?
You just gotta restart it.
So is this clear? If yes, we're going to move on to our exercises. And this time we're going to finish them. Let's make this larger. Okay. So last time we have done number 1. This time let's start on number 2. Okay, let's do this weird sum. Import numpy as np. So it says write a script weird sum that will define vector x, y as x from 0 to 100, and the step size is 5, and then y is from -1 to -29, and the step size is -2. So how do we do this? So which function do we use? Arange. Yeah. np.arange 0 105 5 from 0 to 100, and step size is 5. Nice. Let's do y equals to NP, again, A range. -1 to -29. Let's do 31. Step size is -2. Do a separate line. So -1, -3, -5, blah blah blah, -22, 29. That's what we want. And then compute the following sum. So summation of xi, yj. So we need 2 loops because we have 2 summation sign. One is over. Let's zoom this in a little bit. It's too small. So one is j from 1 to m, and the outer one is I from 1 to n. So how do we do this? We need a nested loop. So you can find this file on Canvas. I've already uploaded it on Monday. Let's do it. So for loop, for I in what? Range. No, let's just do it in a smarter way. X in I in X, and for J in Y. Because this one we're going to visit every one of I and every one of X and every one in Y. So just do I in X and J in Y. So just go to everything of them. We're going to do a sum. So what do we do when we need a sum? Something equal to 0. My sum 1 equals to 0. Notice we have 2 sums here. So for each of the sum, we need a separate variable to hold the value. My sum 2 equals to 0. So why do I put it here? Because every time we calculated the summation of the inside summation, we put it somewhere and we add it to the final result, and then we go to the next I, so I, and we calculate the summation again, and we add the new summation to our final result, and we go to the next I, calculate the inner summation, and we add it again. Let's see. Name my sum is not defined. Okay, we don't have my sum. It's my sum 2. Oh, this is huge. Let's just remove some output. 0. Why 0? Okay, so there is a 0 because I haven't added anything to my sum 1. I forgot that. So after you've calculated, so for example, when I equals to 1, maybe let's move everything into one block to make it clearer. So x is from 0, so 0, 5, 10, 100, and y is -1, -3, -5, -7. So the first value in x is 0, so I equals 0. And then we go inside. Here, we first initiate our my sum 2 equals 0, and we visit everything in y. we do this summation. We add this summation to our final result. And we move on to the next element in X. So now the second element is 5, so I equal to 5. And we do this, so and J.
Hang on.
So are we okay to just jump from simply using the index to allow our I directly be the members of the arrays? Any questions?
What was the calculation for just the I, for I and X?
Pardon?
So just calculated my sum 2, but what was my sum 1?
My someone is here.
Is that the final calculation?
Yeah.
We didn't have to find out what my sum 1 is. That just 0?
This is my sum 1. So equal sign means I am assigning a value to the place named my sum 1. So every time I run this outer layer of loop, I am assigning a new value to my sum 1. I am always writing new values into my sum 1, and the value is the current result. So after we've run the whole for loop, we have the final result in this name. That is a for loop. That is a loop. Whatever kind of loop, it does the same thing. Okay, now let's try to do this one. Yes, you will.
Save it as a PDF.
Yes. So you will have to submit number 2 and number 3. So now let's begin working on number 3. So number 3 says write a script, my product. So menu, file, new notebook. My product. Okay. And we will create a vector x. So let's create a vector x. 1, 2, 3, 4, 5. And let's do the following product. So product is actually the same thing with summation. Just we.
You need to import
Yes.
NumPy.
Yes, we have. We have to import NumPy as empty. Okay. So let's work on this for a moment, and then we will try to work on it together. And I will walk around to help you. About the product sign. So I equal to 1 and that I equals to x1 multiply x2 multiply blah 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 multiply x n. This is what it means. So for example, there, I multiply xi, this equals to 1 multiply x1 multiply 2 times x2 times 3 times x3 times a lot of things times n multiply x n. Yeah. Oh, one thing. So the first element in Python, in the array in Python, is number 0. So actually, it's like this. In Python, you will need to put everything I minus 1. So here it will be n minus 1.
So do we type in x equal or modulus?
So I need to, I remember mom wrote it in R.
How are you going to write? How are you going to write?
So let's together work on this problem.
We have to type this in? Do we type that in to do
Pardon?
this right here? Are we supposed to be typing that or something else?
So that is the meaning of that big pi.
Okay, okay.
That is what it means by that big pi. So here, let's define a thing called my product. If you remember, if we want to multiply a lot of things together, we need to start with 1. Now let's get a for loop. So this time we need this index. So we need to know the exact number. So what is the position we are now inside that array? So this time we have to create an I separately, different from the x. So we say 0 and the size of x. So always my product equals to my product something.
Wait, so why is it for I in range instead of for I in X?
Okay. Because here we say it's the product of I multiply xi. So if we do I in x, we can get this xi because your I is every element inside x. But where do I get this I? So maybe to make it clearer, I say k. Okay. So I need the index as well as every element. So we need to define the index. And from the index, we can get the element. So,
You want us to call it K? No?
well, it doesn't matter. And you have to multiply something to this, and then print the result. That's it. And what is this? You have to find it out yourself. So this will do tomorrow morning at 9 a.m. This is due tomorrow morning. This is something new.